Hey guys, how's it going? Kyle Olson here, just with the next segment for identification and foundation repairs and stuff like that. Sporting the Spartan shirt. Can't really do Spartan races due to medical conditions, but throwing it out there, great atmosphere, wonderful environment. Strongly encourage everyone to check out Spartan races. Very cool. Obstacle course racing kind of thing. Anyway, what we're talking about today is causes of failure, causes of foundation movement type failure, not just any cracking that happens in foundations, but with movement specifically. I'm trying to keep these videos very tight, very short, so I'm going to burn through these things as I go. The first one you've got is static loading. This goes with inferior ground preparation. This is more prominent in different types. So guys, different soils have different types of failures or susceptibility for failure. It's a big thing. So for soft clays, peaty soils, loose silts and sands, you start putting load on top of it. It's the weight of the house. It could be what goes in the house, the people in the house, all of that becomes different loading types, which we'll talk about later with the engineering sections. But basically when the house becomes heavier than the soil support, the house will sink down into it. Same thing with pretty much everything. Next is your groundwater. Now you see a lot of this in San Diego area. Anywhere that has like a lower elevation, the groundwater table will rise and fall. This happens in Brea, actually. Brea happens a lot of this. It's bad. When subfloors or basements get flooded out, or when the groundwater raises so much that it affects the home, it can affect clay soils, soft clays, hard clays, caliche clays. Different types of failures happen there, but groundwater is a big thing that happens. Next up is vibration. This can be heavy traffic, construction traffic, anything going that's shaking the floor, or more commonly, you're in the state of California, you have very high seismicity, lots of earthquakes that run through. So if the ground isn't properly prepared and the soil starts to shake and vibrate loose, right? And once it gets loose, it loses its bearing capacity, and then whatever's sitting on top will suddenly start to sink down because the ground can no longer support that weight. So that is a change that happens that'll cause a house to sink down into the floor. The wetting of soil. I want to say probably 80% of all the failures that we see in residential homes or any structures has to deal with water specifically. So anytime you get soil super wet, you can change the composition of the soil or the physical properties of the soil. Clay soils can expand, sands can consolidate. It's just once you get soil wet due to plumbing leaks or poor drainage or something like that, it can definitely affect your home. So watch out for pooling water around the house. We're gonna have another video about drainage just so you guys can understand sort of how to handle that. On the opposite side, you have the drying of soil. So I mentioned clay soils can expand when they get wet, right? When you have highly plastic clays, that means when it dries out, it'll also constrict, right? So unless you have an engineered fill brought in and put underneath your home, which is, we'll just say, not a common practice, it can still be affected by highly plastic clays or highly expansive clay soils. It's a very common thing to run into, usually with softer clays that won't affect the home, but they'll affect driveways and garage slabs, sidewalks, slabs that walk around the house, things like that. That's what it affects more of and first. But once you get a really highly expansive clay that's very strong, it'll start picking up and lowering the house. So once the soil dries out, you can get some consolidation. Now, quick note, we said wetting of soil and drying of soil. So if I get the soil wet, there's a problem, and if I get the soil dry, there's a problem. So when a home is built, preferably with an engineered fill, and it goes through its compaction, they hit this thing called the optimum moisture content. I think it's something like 19%. Don't quote me on that one. You try to maintain the optimum moisture content, otherwise you may create fracturing, fissures in clay soils, and expansion and constriction. So big part of maintaining a home is controlling the moisture around the property, basically. Another big thing, there's a thing called transpiration. So if you get If you get bushes, shrubs, more big trees that are surrounding a home, remember that a root system can be about twice as deep or wide as the canopy of the tree, right? So if those roots come toward a home, they can pick the home up. Or more importantly, a process of transpiration can occur where the roots start drawing water from the soil into the tree in order to feed it. If that water comes from underneath the foundation footing, it'll again change those physical properties of the soil and create settlement. So you have to watch out for bushes and trees that are surrounding the home as well. Next up, liquefaction. So this happens when you have a high moisture content in the soil and a very specific type of soil and pretty much the perfect recipe of disaster. An earthquake hits and that water mixes with the soil. Imagine throwing soil into a blender with a bunch of water and then hit and go, right? And then it spins around and it basically becomes this milky, liquid-like substance, hence liquefaction. There's lots of liquefiable zones around the state of California. Check out Christchurch, New Zealand. There's great studies on all of this stuff. It excites me. There's some research done in UCSD by the professors down there and some polyurethane contractors, which were great studies. I encourage you guys to look that up as well. But anyway, once the soil liquefies, it loses all of its strength, and whatever's sitting on top goes down. It can create something like a sinkhole, or it can swallow a house or create settlement or a lot of stuff. Anyway, big problem, earthquake thing. One more thing, downdrag on piles. So what this is any piles that are driven into soft clays, any foundation structure that's driven down into a clay. Remember I said I can go to any house at any time and recommend $500,000 worth of work. That includes like caissons, which is generally the more cost prohibitive type of repair, but also the most effective. When you install a caisson 20 feet deep, but bedrock is 25 feet deep, generally all of the weight of that concrete and rebar structure that's supposed to help support the home acts like an anchor, and that down drag will actually pull the foundation footing, pull the house and everything with it that additional 5 feet down. There's this terrible project in La Habra that had exactly that situation, and they had something like 14 inches of settlement through the home. It's terrible. So that's it. That's all I really wanted to touch on was these issues. These are the causes of failure. We'll talk about remediating all of these causes, types of repairs very soon. The big takeaway I want you to get from this video is that every single thing here has to deal with the soil below the home. Very rarely does the settlement and the raising and the lowering of a foundation slab or foundation footing, very rarely does that ever have to deal with the actual foundation itself. That's an important principle because all of the repair options we'll discuss later have to deal with the soil as well as the foundation, right? So I want to say probably 95% of the time, if you have a foundation settlement problem, then it is more than likely going to have to deal with the soil below the structure and not the structure itself. Those become very important when you're looking at how to fix this sort of thing. That's it for now. If you guys like it, check out the other videos. We're going to be exploring absolutely everything. And like, share, click, link, something. I don't know. I'm not big on YouTube. Thanks so much, guys. We'll talk to you later. Hey, guys. I forgot one more thing. My bad, because it's actually a really big one. Oops. So one of the last causes of settlement, and this is a big one, is erosion. So what erosion is that you basically have your house, right, chilling with my terrible drawing, because we all know I can't draw at this point, and your house is sitting on dirt, right? So this dirt down here supports the home above it. What erosion does is with weathering or settlement conditions or whatever else, this soil here can start to wash out from underneath the house. And if it washes out, what it ends up with is you got the soil here supporting it, you've got soil here supporting the house, right? And then there's this void space of just lost dirt that's gone. And this is what we call void space. Creates a void. It's basically pocket void or continuous void. It's a void in the soil. It's empty space underneath the house that has absolutely no load-bearing capacity whatsoever. It's not supporting the home anymore. This is going to be an important concept later on when we start talking about piering systems and polymer and other stuff like that. And the other reason why it's so important is if you've got a house that's chilling on a hillside, right, and you got the slope creep, we'll talk about hillsides later on, and this starts to slough away, it can start pulling this soil out and eroding it off. So you lose soil that way. If you've got a seawall, right, this is a terrible drawing, but if you've got a seawall up here and then you got like the ocean, right, when the waves come in and they crash and they hammer against this seawall, either at the joints or underneath or whatever it is, you can start to wash out all the fines or all the dirt that's back here supporting this area. It can start washing it out into the ocean, which means all of this area is totally unsupported. So erosion is a huge problem. Hillsides, seawalls, anywhere that has terrible climatic conditions, anything like that can help influence erosion. So it's a very, very big cause of settlement. I missed it earlier in the video. I apologize. But it's a concept you're definitely going to want to take hold of. It's going to be very important for later on. Thanks so much, guys. Again, I'll talk to you soon.